Hello, welcome to my channel Chemical Chemistry Classes. Today we are going to discuss some supplementary material. In this we will study Fischer projection, Sawhorse projection, Newman projection, flying wedge projection in detail. So first of all, our first topic is Fischer projection. In this, Fischer projection is a standard method to depict the 3D arrangements. They depict a 3D arrangements of atoms on a flat page. In this method, we will study a tetrahedral carbon that is represented by two cross lines like this. Tetrahedral carbon means carbon is attached to four different types of elements, and we can show this carbon in this way also, right? So the horizontal lines represents bonds coming out of the paper, and vertical lines represents the bonds into the page, right? I will give you one example for this, and that is lactic acid. Here you can see this is lactic acid, this is hydrogen. Okay, this is into the page, vertical line. This vertical lines represent out of the page, and this represents the into the page, right? So you can show this like this also. Hydrogen and carbon dioxide and methane, and we can show this carbon, this tetrahedral carbon, in this way also, CH3, right? So many different Fischer projection can be drawn for a molecule. It is necessary to compare the two different projections to see if they represent the same or different enantiomer. To test this, a Fischer projection may be moved into two ways without changing the meaning of projection, like this. So in first of all, this we can take example of this lactic acid. We can rotate this at 180 degree in clockwise, right? So we get, when we rotate this in clockwise, we get this. Right? And rotating this Fischer projection at by 180 degree. Now, hold any one group steady and rotate the other three. We can just hold one group and rotate the other group in either direction, in clockwise or in anti-clockwise, right? So we are holding hydrogen steady, right? We can hold hydrogen. Okay, when we are holding hydrogen, then our structure is, and we are rotate this all three in a clockwise direction, then we get this, right? So this is Fischer projection. Next is Newman projection. In Newman projection, the two carbon atoms in a molecule like CH3 is replaced by other substituent, right? So the center of the circle, like this, the center of the circle represents the front carbon atom, and the circumference of the circle represents the back carbon atom. The substituent attached to these carbon atoms are projected into vertical plane, and the bonds thus appear as the spokes of wheel at the angles of 120 degree for each carbon atom, and the spokes of the rear carbon being displaced by an angle of 60 degree. So with respect to the bonds of the front carbon atom, for example, the CH3 like this. So this is the front sides of the carbon, and these are the substituent. When we rotate this, then the substituent position is replaced, and I will show you. We can rotate in either direction, in clockwise or in anti-clockwise. So we get this, like this. This is the eclipsed form of ethane. Next one is Sawhorse projection. In this, carbon-carbon bond in two adjacent carbon atoms displaced by a larger diagonal line which is taken to the plane of the paper, and the substituent attached to these carbon atoms are projected above and below the plane by small lines. For example, the Sawhorse projection of CH3 to CH3, right? So 1 2 3 4, right? So since there is a free rotation of second, I will write here, second and third carbon, they can rotate freely. One can draw other conformation of the molecule by rotating this substituent of one of the carbon atom in clockwise or in anti-clockwise. So the conformation is like this, right? Right, so this is 1 2 3 and 4. So second and third carbon can rotate freely in either direction, clockwise or in anti-clockwise. So this is what the conformation in staggered by form of butane. This is a staggered, and its eclipsed form is like this. I will show you. This is the eclipsed form. This is a Sawhorse projection. Next is a flying wedge projection. In this projection, two bonds of carbon atom are shown in the plane of the paper, and third and fourth carbons are shown as the projection in front and back of the paper. The bonds in the plane of the paper are shown just by an ordinary line. This is what? This is a plane of paper, right? And the bond above the plane is projected like this, when they are above the plane, right? And the bond below the plane is projected by dotted line, like below the plane, right? So this flying projection, I will explain you with one example of lactic acid, that is 3-bromobutane-but-2-ol. I will show you. Like this is a lactic acid in positive form, and negative form, right? And this is lactic acid. I will show you another example, that is of 3-bromobutane-2-ol, that is like this. Like this is for, and the other rotation of this is like this. This Br is exchanged here, and this H comes here, and this like so. This is all about flying wedge projection. Thank you.